Okay, I'm gonna work on my RPG simulator. Right now, when I run it, it's crashing. So I'm gonna go. Just run it in the debugger real quick and see what that is. The set is a null. Okay, got it. So to give you an idea of where I left off, I'm working on this proto file here, and this pair of files, the proto layer, and I was just about to fix a bug in it, so let me get that done before I forget what the bug was. String ID set equals RPG string ID set begin. Oh, but that requires to know the count up front. Which this doesn't do. I wrote the old so the simulation is just something small to test the simulator. I'm still developing the simulator. It's not like a finished thing. So I'm trying to figure out good ways to be able to program it so you can program games into it more so than to simulate existing RPGs. Although I think the other thing would be cool. I'm not sure that like you could. It'd be pretty hard to make a generic RPG simulation that could cover lots and lots of different kinds of games. You know, lots of if it there's just so many different ways to put together an RPG that I don't know that even if I came up with a pretty good generic way of programming it, it'd probably be only 90% correct for most RPGs you could pick off the shelf, right? Okay, so that's just gonna suck for now. And that's gonna go on the arena perm. There we go. Okay. Nice, okay. Yeah, this is getting nasty complicated. So what I was going to do is I'm going to show you a little bit about what I'm doing with the proto. So if we look at tile H, so this was stuff that was already in the new simulator. So the new simulator used to have tile, character, party, and route built in. And then there was like a tile proto, which isn't really finished yet. This is just sort of a placeholder for the system. The character proto, which is a little more interesting. The party proto, which is this, which looks different, but it's actually just a subset of the character proto fields, because this is, this is a bunch of pointers to characters. This is a bunch of IDs to tiles in the tile system. And then if we go to the route proto is just a bunch of pointers to parties. Now that's not the way it'll be forever. That's got to change someday. But that's the way it's structured right now. And so all of these are like, this is an array of pointers to these. This is an array of pointers to these. And this is not an array of pointers, but an array of IDs back to these. And so all of them have this array of elements of the next tier down. That to me signaled that it's time to Lego brick the data structure. So a Lego brick is when you say you take a bunch of types that you were treating as different types and you now make a single type that can act as all those separate types fully, but also interchangeably. So that's what the just raw proto means. Instead of having a proto of all these subtypes, I put it together the proto that has, it knows its own ID, which is new. It knows what kind of proto it is, which is not new, but it's runtime information in the proto instead of just static type information. This came straight out of the character proto for now. That might go away. And then there's the list of IDs, and now every proto gets a unique ID in the whole system, right? So that's the thing I'm trying to build, is a Lego brick version of the separated types. What I've got so far is I've got a construction process, so I can create one of these proto construction systems or types, instances, and I can start adding protos to it. I give them a kind and a name, and then I can equip other fields to them. And then it ends, and the name here has to get mapped through to an ID because I store the sub IDs as, or I sub the sub protos as IDs here, but I don't want to have to deal with them as IDs from the user side, so I put the name API here. This is still all rough. I don't necessarily love that. There's something, this is starting to remind me a lot of building a type system construction system, and so I might structure it that way. It feels like the right metaphor for that particular data structure. These are just helpers. They wrap this is like a little language for building a proto, and then this is actual proto constructors that I want. This here converts the construction type into the proto set, which can then be used for all of the main operations. So this is just the final baked version of the data structure, whereas this is the one that's being constructed on the fly. And there are a couple things I want to think about and work on here. One of them is this context problem. This is feeling like it's getting out of hand. And I think that might be the right place to start. I might need to make a map of my current new architecture and run a simplification through it, because I'm getting to the point where I had this concept of a context. Let's go look at that. I had this concept of a context, and the idea was going to be that once you had done all of the construction for all of the static data, basically all the protos are just statically defining the structure of the game. They're like a type system in that way. It's set up ahead of time and doesn't mutate. It's the structure on which logic is projected, or through which logic is projected, perhaps. And the question then was, well, what's going to happen? The idea was, what's going to happen is that I'm going to build that type system, put it into a context like this, and then that context can be used in things like the parser, which gives you ways of putting together the routes more organically. But then it actually doesn't even make sense, because now that I'm collapsing it down into a single, proto, it doesn't work the way it used to. This used to have special logic for each step. So when you were going to build a character proto to parse, you would only have to pass in a tile set, right? Because there wasn't a single context, there was a tile set. And that was because the proto for tiles was separate from everything else, right? And then it got annoying to have to pass that around all the time, like all these separate struct pointers. So I bundled them together into a context. And now the context itself is just containing this bundled together proto set. So, I mean, there's also this errors thing. So it's not entirely wrong that it's the context, but the more important point is the proto set is under construction while we're building protos, but now we're using this, we want to use this parser to construct things. So I've kind of done it the wrong way around, and I need to sort that out. So what I'm going to do is I'm going to make a picture. Having talked about what I am doing, I'm going to make a picture of what I think is the correct thing to be doing. I have a couple things to relate to each other. I need to construct protos. I have an ID system. I need to be able to deal with strings. I'm also going to put in a separate concept of script, which is a little different because these parsers parse scripts. And that's different from the names that I'm using as strings in the case of Protos. These are just like identifiers. I guess yeah. So the strings that come in here and get turned into IDs in the string ID set. Right, so that's part of it. Script. And there's going to have to be a context. Those are the unavoidable types that I need to deal with. All right, so I made my little picture just so y'all can see what I do. Do you see this? I don't know if you can see it. Let me pull up OBS so I can tell what you can see. See? All right, so I wrote down my list of types that I need to deal with. I think that's everything. Now what I'm doing is I'm going to try to map out the various arrows that the system actually needs in terms of these types. I tried to keep the set of types minimal, so I didn't throw in the string set. I didn't throw in the proto set. I didn't throw in the arrow. I didn't say anything about what context needs to mean or any of that. I just wanted to have the main poles that I'm feeling like I definitely need to distinguish from this system. Now, I need to throw in a little bit about the construction of protos, because that's a part of what makes this complicated too. If we look at the proto right here, this whole thing here is a part of the mess. What I'm trying to do here is deal with the fact that a proto is basically, it's got a kind and a name, call that its string, and right now it has hearts and strength. That might be just eliminated later. I'm going to leave it out of the sketch maybe. If I leave it out of the sketch, how am I thinking about it? I'm thinking about, no, I'm going to put it into the sketch for now. I don't actually want to do the work of holding that abstraction in my head. Hearts and strength are just integers that need to get carried around inside this thing, nothing special. And then I need a list or an array of IDs. I'm also going to say, okay, right, so there's the contents of a proto. Do the face again. Contents of a proto. A proto is a kind and a string, hearts and strength, and an array of IDs. Okay. Now I need a list of some of the operations we need to be able to support. Given a context and a string, I want to be able to get an ID. Given a context and an ID, want to be able to get a proto. What else am I missing here? ID from name, proto from ID. That's pretty much it. I mean, there's count. So that's what the static context ultimately needs to be able to do. But then the problem is the parser, which is going to produce protos, also needs to be able to do this. So this here is the mapping mechanism, which always needs to be provided. The parser needs to be able to do let's see here, a context and script to proto. And it actually just does that in three ways. Now the character template part is a little different. What is that? Character template. That's using an identifier to look up a character instead of a character literal proto. Like, that's a character literal, basically. The pluses and the number and the dollar signs, that's character literal. This is a character identifier resolution. So why doesn't it return I see. So that's not even wired up correctly yet. But what that could be doing is just returning the character proto instead of the ID. The reason it was returning the ID, what is that? It would take the character template and use that to get the proto. And here it's using the proto. Character template. So the only user for that actually just wanted the proto, not the ID. So that's just garbage. I don't need that. But this comes in multiple variations. So it's context and script to proto with with character literal character ID party literal and route literal. Those are the ones we have so far, at least. Be right back. Okay. So I was, yeah, almost done drawing that one. So, again, showing what I've got. Start with the types, right? That's the list of types I want to deal with. Then I wrote down the idea of what that goes into the proto. Here we have the concept of all the mappings we need to be able to do. Once we have a finished context, or really anytime we have a context, we want to be able to build these contexts up incrementally. And so we want to be able to put in a context and a string and get out an ID for that string. So string consting of some kind, put in a context and an ID, and get out a proto. So each name is a name for a proto now. There might be some times where we want a proto, like if this does build out in the same way a type system does, then, which is what I'm kind of anticipating, there might be some times when we want an ID for a proto, but that doesn't have a name. That's certainly right now what the routes and parties are like they aren't actually named in the scripts. They're just constructed as is. Sort of like how in array you don't, how do I want to explain this? If I have in C, if I have a type system and I have like int, that's the name of a type, but int star is a type whose name isn't any identifier, right? It's actually, there's no single string that represents this. All of these different ways of writing int star refer to the same type. That's because it's constructed by an operator rather than being a named thing. And so I might have the exact same sort of pattern showing up with the protos here, I think. Sorry, when I was showing the ints, I had my face covering it. I mean these things, right? These are all the same type. They don't have a single name. There's lots of different ways to write it because it's a type constructed by an operator rather than a type that is given a name. Okay. And my character, my RPG simulator proto data structure is probably going to work the same way. Okay. So now I'm going to start showing how these modules need to function with some arrows here. This is different from a mapping arrow. This is a dependence arrow, so I'm making it a lot thicker. But I need to be able to write this in such a way that the parser can use the mapping, which is not what I was taking into account before. Besides that, I also need to figure out what the API for constructing these is going to look like. But I think the right thing to do is going to be another clean slate rewrite on the context proto set parser compound of things that I have going on. So let's take a big zoom out step. This will get a little wild now. I'm going to put everything but registry. I'm just going to wipe out all of it. Registry is fine, but the rest has grown in slightly the wrong order. So we need to yank it all out. Yank that all out. We'll try to rebuild that little bits at a time. Okay. So, unfortunately, some of the file names I want are taken. Let's see. Okay, so the way I want to do this, I'll keep errors, I'll keep context. Just looking for a transition path here. I know what I'm trying to write. I'm going to use an errors and a context. We're not going to do Protos separately from that. So all of that will get rolled into this. And then parser should actually be fine the way it is. Okay, now this file is now going to take on some other stuff. So there's nothing wrong with the proto itself. The proto set and construction are wrong. So I'm going to ignore those. We know that much is correct. And then whatever's going on here with protoset, protocons, I'm going to ignore and kind of reconstruct what I think belongs in the context from first principles off the picture. So some functions we know we need with the context are, we need the mapping functions. These do the following. Count RPG context function RPG ID from name RPG context name, and then RPG proto from ID, RPG context, U32 ID. So there's our mapping system. There's not going to be one of these. I kept errors. I think that's simple enough for now. That might still end up being wrong. Honestly, why don't we just do this? Why don't we just do this? So we can make you go like that. Did errors.c have anything? No. Okay, so that would mean you're also out. Now what we need is a construction function. So we need the ability to submit a new proto into the system. Now, I have right here written down what goes into a single proto. The question is, how do I want to make this into an API? I could have all of these be parameters, so then you just pass, 1, 2, 3, 4, 5 parameters. I happen to know that these are going to change a few times. I think hearts and strength are going to get folded away at some point, and it might turn out that I want to add stuff. So if this is going to change, then the function signatures are going to change, and function signatures changing is a pain in the butt. An easier way to do it is to make it a struct. But this is a different struct from the actual proto, right? The actual proto, like the low-level one, looks like this. It's got a kind. Instead of a string, it has an ID, and then this part is self-explanatory. I think we need like a loose proto or something. Proto loose, maybe? Proto kind, string 8, name, hearts, strength. And then this part's interesting. How do we want to get a list of IDs into it, considering that the user who knows about these probably knows about them as a list of names. So maybe this should be like this, like sub protos goes in a string list. So another concern this raises right here is, what if I end up having things that are referenced here that are actually going to show up in the future? Or am I saying that I always have to present stuff to this already topologically sorted by its dependencies, right? Like, am I going to submit the proto loose to construct a new proto? It'll use that name, and if that name is not already taken, it'll assign an ID for it, and then create the proto with that kind, the ID for that name, the hearts and strength, and then the idea right here would come from just resolving these. These would always have to be resolved already. Or is what I'm going to do is have this allow itself to reference anything, including things in the future, and keep them in a state of non-closure until the time when they are finally closed. Or even am I going to keep them all loose and operate with them that way, right? The downside of operating with them as just loose protos all the way through is, while I am thinking about it like there's the static part and there's the construction, there's like the construction phase and then it's static for the run of the game. The truth is it might be, that might make it really rigid and black and white to deal with. And it might be necessary to be able to be a little bit more fluid with it so that you can create processes like, you have the game that you're shipping, which has some static stuff, but when you go to generate a scenario, when you go to generate, if it's procedural generated game, or if you want to be able to program the simulation to put it in terms of simulation, if you want to be able to have variants of your simulation and run lots of them, you're going to want to be able to write code that constructs these things and then seamlessly run with that context and then modify that context or modify a copy of it or something, right? Keep a basic copy and add different variations onto it over and over again to build up the different simulation cases, right? Or maybe the way you want to think about it is the context contains these constructed things, and those constructed things, like int star, right? It's not like you're going to have two different int stars that need to mean different things become a problem. This constructs a type of a specific meaning. And so maybe the context wants to get reused in between simulation runs, and it's just accumulating these protos, but it's going to go back into construction mode in between simulations once in a while when a new proto gets added into the mix. And I'm pretty convinced that that's an accurate way to look at it. I'm going to want to be able to submit things and use them, and I don't want to have to deal with them in terms of string lists. This will be too, like, I want to be able to run things faster than the max speed I could get out of this. So it can't just stay as a string name in a string list. It needs to boil down to IDs in time for it to be used. That's, I think, the point. But I also want to be able to grow this thing in place, right? So we're taking on the how do I like to call this? It's not just a read only, write only data structure pair, but it's actually a read write mutable data structure design problem. Okay, so good to know that. Now that I can just accept that, I'll build it that way. So to build something like that, what I'm going to need to be able to do, well, there's the other piece, which is for now, I'm not going to try to defer these into the future. But I'll make sure to build an API that could work that way. For now, this will just be an error if you submit one that can't be resolved. That's all we'll do is error, but we'll have in mind that I want to do something else. So here's the proto loose. That constructs a new proto. Then if there were any errors, that would come back in the context system errors. Hey, Mr. Mixer. Or are you someone else? Mixer ID, I don't know. Well, either way, welcome. Okay, cool. Yeah, I've noticed the various variations. Put on some music for me. Okay. So when we make one of these, it has to be able to resolve right now. But it goes into the system and works like this. Now, that means we know what we have here. We have an ID system for non-freeable entities, right? The protos, once they're constructed, stay in play. We're not talking about freeing protos. These aren't entities in a game so much as they are the sort of tiles that are being used in the sort of construction of a game, the setup, the world generation, so to speak. Where the world is a simulation of an RPG, so the world generation involves whatever is involved in setting up the simulation, but it runs in that phase. So there's no freeing of the protos yet. It's just adding them, which means our array doesn't need to be generation ID'd or anything like that. We're just going to need to be able to have a dedicated growing array for RPG protos. And so that could go in its own arena. That way it can be a non-growing. It's a fixed array that has a max that we're comfortable with that could be reserve commit, or we could just make it a huge max and allocate it all up front. What do I want to do there? I guess I don't want to get bogged down in making this super hardcore yet. So what I'm going to do is put in a cap of like 10,000 protos and just go for now. Okay. Because we're also ultimately going to need this, is where we're building. We need to be able to RPG context new. Um, okay. We need to be able to create buckets of string mapping. Now, like I said, we need an arena for the Protos. Well, we don't necessarily need that. What we need is a permanent allocation. So we'll put in an arena for that. But the bucket's going to want to be able to reallocate. Well, a string bucket I haven't actually designed yet. It's going to be like this. It's going to be just a simple linked list chain for hashing for now with a name and an ID. Maybe also a hash for fast comparisons. I don't know. Something like that. I think we'll just do it like this. This is the plan. Hey, young Lane, how's it going? That's going to give us a way to do... Okay, okay. We're going to end up with some internal functions that are currently missing, but that's the main idea. So, let me try to build that. That's awesome. How's your UI library coming? Like, are you feeling like it's super useful, or are you still... I always get stuck. I'm asking because I always get stuck in the UI library process at the very beginning. I'm not great at the UI library thing. The few UI systems I have built were usable, but It's just not my forte, apparently. Okay, to set this up, let's also throw in the Protos and the Protos cap. And like I said, let's give it like, I don't know, 10,000. That should be good for now. That's cool. Tell me more. What are you doing with the UI box? Alright, so we want a for loop or the RPG string bucket. Bucket index. If the bucket we're looking at has the right hash, and when we double check, the bucket has the right name, then the result equals the bucket ID, and we break. Okay, so by UI box, you just mean the Lego brick approach where you have like a tree of stylized rectangles that you can program. Can you articulate what the downside to that is? I've never really felt torn on it, although I've never been very good at UI, so it's not like I'm sitting here thinking this is working out perfectly for me. It's usually just that I tend to think the problem is more that I just don't have the patience to develop like very nice looking and feeling interactions no matter what type structure I use. But I'm curious if someone like you who's actually pushing past the basics and getting it to the point where you think it's kind of working, but you're saying you're torn on it. What's the downside to the UI box from your perspective? Okay, so that's how we do the mapping to the ID. And then for this one, the first proto will be the nil. I see. That feeling that it's wasteful can be hard to deal with. I think tastefully compressing it is like a part of the Lego brick design process for me. Like I get to a point where my Lego brick is working, and finally, if I can get it to the point where it's finally doing everything that I want it to do, and then I stop and look at it and think about it, there's usually tons of ways to compress the Lego brick down. But with UI, I can never get it to the point where it's even doing everything I want before I get flustered with the system. I mean, the best UIs I've ever built weren't UI libraries. They were just purposely tied into the logic of the application underneath. And they weren't even particularly clean or fancy looking UIs. They certainly weren't idiomatic. So all right, so now there's the new proto construction problem. So in order to do this fully correctly, first things we want to do are the proto loose needs to have needs to be validated. So if the colliding ID does not equal 0, then we have an error, and we're invalid. Now the final way we can be invalid right now is that we go look through these and one of them doesn't resolve. Mixer, when I do it, I have tried to do the flag thing, and I like it that way for clicking and dragging and um, a few of those things, but I always feel like I'm missing something. Like there are more flags that I could imagine finding that would make things go farther. I think the part I have the hardest time with, though, personally, is just managing the logic of layout. I don't really understand the flow of the constraints of like, okay, I've got some things that are just a fixed size based on pixels or based on inches or like based on unscaled pixels, and then DPI has to apply, and then there's questions of like, okay, well, if I render with a string, how wide this thing will be might want to depend on how wide the string is. How do I specify that? What is the logic? I don't know, and I don't really ever feel like I do a good job of understanding that. And then there are like layout things of like some things fill up, a set of things fill up the space that they contain, whereas other things stack in tightly, and some things create scrollable sections and some things don't. I've never really come up with a language for all of it that doesn't overwhelm me. I still strongly feel like I would rather construct UIs visually. Like a form constructor is halfway to the right idea. The problem is just that we don't know how to build the programming. Um, we don't know how to build the programming that goes with that interface yet. I don't know what you mean by rect cut. No. Okay. All right, what I'm going to have is I'm going to have an arena temp up here called restore. This is a restore point, so that if I decide I don't want to construct anything, I'll just restore the memory back to the way it was before. Okay, yeah, I know rect cut then. Yeah, that's not the part of layout that I don't understand. The part of layout that flusters me goes deeper than that. It's like um I mean, yeah, that's cool. It's just like really useful layout systems will have language in them for things like, okay, this is a centered piece of text that fills the entire width of the available space. And that's different from knowing how to put together a layout language like that is the part I'm saying is difficult. The algorithm for splicing up rectangles, I kind of got that stuff, in like 4Coder. But yeah, it's an important building block at least. Okay, so the goal is loop over the nodes in the Protos, subprotos. With each of these, we go sub ID index equals get the ID. We want to get the ID from the context. ID from name, context, node string. If the ID ever equals 0, then valid not. It is not. We'll break out right there. And we'll set up an error. And then for all of these, I should also just do the logic that we only actually keep going. Oh, that'll be good. That'll be good. We'll get rid of that. Okay, this is good. Yep, so we'll do the validation phase like this. So we do all that. If we get to the end, then we'll end the temporary restore point, and that'll be that. So we won't have allocated any memory in case we did, and we'll let the error pass to the other side. If it did come out as valid, then store the new proto. Buzztronic, I did do some C++ once upon a time. I touch it, but I generally stay in the C category of C++. And lately, like in the last few years, I've just been pure C most of the time. I like that it's easier to deal with in the linker, and it's so many more compilers that are actually fully C compliant, and it's easier to build one from scratch. The Microsoft compiler made it seem like C was the rare and unreliable thing once upon a time, but that phase has passed. Okay, here we can put sub count and sub IDs. Okay, we're getting there. Now I still want the logic for storing it. So there's all of validation. Now, if we validated successfully, how do we store the new proto? Well, let's get the proto we need to fill. That's going to be context protos plus ID. Let's get the ID for this thing. That's going to be context proto count. And then the context proto count can increment by 1. Okay, so that takes a proto. Then we're going to want to fill the proto. Sub count. Okay, so there's filling the proto in. We still need to store name in the map. We allocate a new bucket on the arena. We fill the bucket in. So the bucket gets a copy of the name. We copy it just so that we can be sure it'll live long enough to stay valid without having to think too hard. We give it the hash and we give it the ID. Then we stick it in to the buckets that already exist. Now that's cool, except in order to do this part, we first want to make sure we grow the map if necessary. So for this, what we're going to do is we're going to say if the context bucket count becomes less than, well, bucket count string count. Yeah, so the new string count is going to be whatever the current string count is plus 1. If the bucket count becomes less than the new string count times, let's say we want a ratio of 4 divided by 3. Then we need to grow. New bucket count equals a line up power of 2. New string count times 4 divided by 3. New bucket arena. We'll just use an arena alloc and release method here to make this simple. So we make a new bucket arena. We allocate the new buckets. Onto that arena. Then now we've got new buckets. I'm gonna get a new bucket mask equals new bucket count -1. Okay. Now what we can do is we're gonna loop through everything in the current buckets. String bucket. This is just going to be an infinite loop. This is going to look like an infinite loop. The way it's actually going to work is if the context bucket I equals 0, it breaks. Otherwise, we'll go RPG string bucket equals, grab that, stack top, and then we will take new bucket index by going bucket hash mask new bucket mask. We'll do the SLL stack push of new buckets, new bucket index bucket. Okay, so we grab the bucket off the top of the stack, pop it, find out the new stack it needs to go to, and then push it. We do that until that stack is empty, and then we do that again for each stack in the array of buckets. So Mixer, I hear what you're saying, that seems like the logical thing to do, except that it takes so much darn typing then, right? If you have to pass an input size, and the input sizes are all these like long named things too, and that's for X, right? This is you're passing a size for the X component, and you also have to pass a size for the Y component or something. I mean, I don't know how to do all that. The old no talking tag is old. Let me remove that. Thanks for letting me know. So once you've done all of that, then the context the old bucket arena can go, and then we keep the new bucket arena, and we keep the new buckets, and we keep the new bucket count. We'll also set a minimum of 64. Feels silly to have it grow the first couple of times from 0 to, 4 or whatever, and then, or what would it be? I mean, the very first one would be, it would grow to 1, and then it would probably grow to 4. Seems silly. Start off at 64 and let it not have to grow for the common case of a few protos in the simulation. Oh, whoops, not align up power of 2, it's next pow 2. I see. I see. That's a cool way to do it. You set the button to have a default sizing rule, and then that usually works, but you can override it by additional calls after the element. That seems like a good way to do it. Okay, that's not relevant yet. That's for when, well, I guess if all of context is building now, then yeah, let's look at parser. So character proto cons, what this is actually doing is basically a proto new. But this constructs a character without a name. So yeah, the part of this that sort of sucks is now I'm running into this problem where the parser for the script is being interpreted as always being used to update the context with more information. So I don't have an interpretation of the parser as just a data in, data out, right? Even though I could, I can't if the goal of it is to go all the way to a proto. So maybe what I should do is I should have the parser be rewritten in its purest data in, data out format, and then wrap that in a construction later. I didn't do it that way before, but maybe that's a part of the mistake too. That means I need to just kind of rewrite the parser while keeping the old one in place. So the way I'm going to do it is I'm going to, well, rename each of these. Okay, so there's the original version. Now let's try it again. Still gonna have this. Still gonna have this. Still gonna have these. Now, where it gets different is instead of returning protostars, these need to return things like this. So character literal, that's where we get the hearts, the strengths, and the list of strings. So the things that can go into party are character literals and strings. So it'll be like that maybe. Once again, looking at the literal level, I might want to have the literals Lego bricked. You know, the entities in the runtime got Lego bricked in the first pass. Here, halfway through the second pass, I decided to try to Lego brick the Protos, and now I'm discovering that Protos and literals are different from each other. And the impulse is always to Lego brick it again, but I keep wondering if each layer of Lego bricking it kicks the can down the road to the next layer to have to do it, to undo it. Because it feels that way, but there is something different, which is that either way, having the parser be dependent on the context means that you can't use it for pure data in, data out. You can only use it for introducing new things into the context. And I can't quite decide if I want that or not. So that's the real confuser here, stopping me from more easily figuring out what I want. Okay, parser X, parser. We want to make sure that the functions we carry over into parser match the type signatures from the header. Okay. So how does this work? Character proto has done all this work. Where does it start talking to the context? So that won't fly anymore. And this won't fly anymore. What we're building at the end here is a character literal. Later, Mixer. Okay, so this arena, why don't we mark that with an arena temp? Because if we end up not finishing the construction of the literal, then set that there. Just do it like this. Yeah, Paging Turner. Paging Turner says that the uh, the Lego brick style simplifies certain things like the memory management, but it also introduces potential new bugs because now you don't have the benefit of the type checker catching mistakes, and that's 100% true. That's like the thing. It is a step in the direction of dynamic typing. I mean, you're still writing code in C, so you still have all the memory management, you still have all the low level operations, right? You're in that world, you're grounded in it, so you can work that way, but you are taking on dynamic typing as a tool in the structures you're working with, and so you do end up with those kinds of runtime errors. Now, the way I tend to like to do it is to have, well, for one thing, you want to make sure, like, you know, your builds need to be fast. You need to be able to get from modifying your code to seeing the effect of the code as fast as possible. It's one of the things that gets frustrating about working on games when you don't have hot reloading is that, like, the bug, it takes 5 seconds to set it up. So if you make a tweak and then you run it again and you're like, okay, what are the 5 seconds to set up once I've started the game and I'm running it, and you see it and you catch it and now it's in the debugger, and that 5 seconds is a little bit annoying, but like then you get used to it, and so you allow a 10-second bug to take up your time and a 15-second bug, and blah 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 blah, gets worse and worse. And the compiler moves the bug up in time to the compile time, so when you lose that, and now your bug is buried deeper in time from the moment you run, that can be a real serious problem. So having ways to jump straight to the thing you're currently working on as often as possible, never letting yourself build code that is buried 6 feet deep inside some complicated interactive process, is ideal. It's not always possible, but it's ideal. Okay, there we go. So that's how we construct a character literal directly now. Let's grab the next one. So the next one is the character template. And right, so here, this one's in just in simple, straightforward cascade mode. How do we do this? Name equals 0. Move this to the bottom. Well, I mean, not literally this to the bottom. Let's do name if we actually catch a name, then we fill it in. There we go. Yes, this does now take an arena. Now, things might get better if we switch the string consing to be proto, like, more base layer than it currently is, because a parser could still benefit from a string consor separately from having it tied in with the proto ID system, and that might be a good thing to do. Okay. Another big part, since there hasn't been any other talk on it, I still have it on my mind. Another big part of the toolkit for responding to those kinds of Lego brick runtime errors that can be produced by the permissiveness of a dynamic typing is you can it's what I call the error-free system. You have a nil error node, and you're trying, or type node or whatever. Your operations start to converge on this thing of taking in one or more nodes and returning a node of this Lego brick. And as it gets closer and closer to that, you end up relying more and more on the idea that, like, okay, sometimes a node comes in that just doesn't make sense for the path that it's on, and the result is to short circuit and return a nil. And the more of that you can do, the better, in my experience, because then you do that and you throw in on the side a side channel error system like the one I build, and the two go together very nicely if you see how they block up to each other. It's a little hard to show because C doesn't make it obvious that they can go side by side. Okay. I'm using a separate arena, the one that I built in the Mr. Fourth Base.h. But I designed both of them, largely. They're very similar arenas. Yeah, the zeroed struct for as a pass through, like, it's basically my approach to errors is somewhere between it's something like exception handling, except I don't unwind the stack, and I don't do this stack unwinding, exception catching stuff. Instead, code always moves forward, right? Execution always moves forward through the code, which means if I call a function, it will return, unless it gets infinite loops set aside, right? If I call a function it's supposed to return, it will return, it won't throw. But I want to be able to create stacks of error awareness. I want to be able to say, within this block, if an error occurs, I am going to inspect it and handle it. So, like, if you're making a library and it's going to have errors, but then the point of your application is to create an interface for doing operations within that library. Like, say you want to take a font rasterization library like FreeType, and you want to be able to put a UI on top of it so that you can basically look at all the data structures and bitmaps and, you know, geometric shapes and stuff that libFreeType is extracting out directly. You want to make a visualizer for the FreeType data structures. Well, in that case, errors in the API wouldn't mean we need to crash and fail. They would be things you would want to also include into the interface that you're building. So the meaning of error shifts at that level from failure of the system to just data that the UI system wants to deal with. But then another user might say, okay, I'm a game, I have a font that I rely on, that I need to be able to load, and if anything goes wrong in that part of the process, let's just throw out an error window dialog box explaining that we couldn't find or parse the file and get out, right? That's also reasonable behavior for a particular, like, kind of package that you might ship. And so you need to be able to shift your relationship to error information in kind of a try-catch way, but there's no exception unwinding. That's the way I do it. All right, so we want to try to recover the party parsing. Here we've got task of making a party literal. may also want restore again. I think we're going to push some stuff onto the... Oh, I guess not. Okay, we're going to have to figure this one out in a couple of steps. Party proto loose. Don't care. Oh, Young Lane, I didn't see your Unicode question. Go ahead and ask a Unicode question. What do you mean? Okay, so the question is, how, in a simple text input field in a UI, how would you store and detect the different widths for Unicode characters that have a different width from ASCII characters? Even though you're using a monospace font. Interestingly, I think that I would approach the question a little differently. This is basically a question of how do you stop using monospace? How do you deal with variable width fonts? If you could deal with variable width font, then you wouldn't. That would be the difference, right? Am I right there? Or are you talking about Unicode characters that take up multiple tiles or something? Like, do you want to have it be that it's always aligned to a grid and your Unicode characters just fit within a Unicode chunk, or fit within multiple tiles? Because if you want to do that, I would still just handle it as a variable width font personally, because handling variable width fonts isn't that much more complicated than handling multiple tiles. But there is a difference. Like, as a matter of if you want to lay things out that way, that could be nice. And also, it's different because well, you have different options for how you can like render it if you keep it perfectly tiled. But I think the easy way is to just handle variable width fonts. And the answer is you don't store it and detect it. Yeah, so my point is there are two layers to keeping it tiled, right? One layer is if you keep it tiled, it's just a matter of the UI, like that you care about that's how it looks. But there's another layer which is like you have architectural stuff deep down in the rendering paths that rely on it being very tiled. It's not like, one way to render a string is to just draw a character, move over, draw a character, move over. Another way is to imagine and impose a grid onto the system first and to fill in characters for each cell in the grid. And if you do, or glyphs for each cell in the grid. And then if you have Unicode characters that are going to span multiple slots, you would have that could be a single glyph that will be placed on the first tile, but when you render it, it's actually wider. But another way you could think about it is it's just multiple tiles need to get set by the same Unicode character. Now, the way you would achieve that would be the same way you would achieve implementing a variable width font. It's just instead of doing pixel granularity variable width, you'd be doing tile granularity variable width. But like the processes are the same, which are you have your string. If you want to just render it, you just do a layout, and each time you render a character, you put down the glyph or glyphs relevant for it, and then you advance a certain amount based on whichever character you put down. If you need to be able to click on it, like and interact with it, then you save the layout data that gives you a set of rectangles for each character, or it might be like a height for the whole line and a width and height for, or in a X and width, or a left and right edge for each glyph, but somehow for each glyph you know where they start and stop on the screen as layout data that you keep for mouse purposes. So then when you get a click, you can look at that. Another thing you can do is you don't have to keep it, you can just derive it. So you have a click, you know it's in the text field, then you go to run the string layout and you compare the layout. Like you could be running that string layout every frame if it's a single line of input. But then you're taking the data structure comparison that you need is you need to compare the point to the layout data structure for your string, one way or another. Okay. I've never actually done a tiled. I've never actually done a tiled Unicode handling string system. So I'm also just speaking extemporaneously on how I would go about doing it based on experience. There's probably more that you can do if you get super serious about it. Okay. Okay, so member here. Character name equals the character name. If the character lit does not equal 0, you do it this way. So let's see, this is lit local first, lit local last. The member goes there. And then the copy member goes there. Copy member is lit equals member is lit. Copy member character lit equals member character lit. And then it goes there. Okay. Finish means we go RPG party lit equals we're gonna want a restore point. Begin temp arena. RPG party literal 1. And lit is gonna equal the lit local. And then at the end here, if lit equals 0, then we're going to arena end temp the restore point. So we only keep the memory we allocate if we actually did construct a full party literal. And it comes out as a party literal. Perfect. Parser X. Party gets replaced with route. Restore. And temp. Route. Bye, paging. Thanks for coming to hang out. Okay. Okay. Let me see here. So there's party literal from parsing the party. And then we grab a member. Route literal member. Member party equals party. SOLQ push. Lit local first, lit local last, member, lit local dot count plus equals 1. I think I've skipped that on the other one. Let's go get that. Lit local dot count plus equals 1. Now, this sucks because I haven't actually been passing that through, but I'm actually depending on it at the end, huh? Well, there's an alternative. For now, we can just say if party equals 0. This won't be correct forever. Okay. Now, parser x. These should be taking the script parameters, not the parser again. That's the whole point. There we go. Okay. So now the big question is going to be, what do I need to test out here? The parser yeah, so the only way to test out the parser is to just write dumpers for all of these and then make sure that they're working. I guess that's what I'm gonna do. Sure does make me wish I had already Lego bricked the literals. Let's take this in baby steps though. We're just gonna do the extra hard work. Literal, 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 literal. Instead of calling this template, we'll call this character ID. Character ID. Template becomes ID. Template ID, template ID, template ID, template. There we go. All right, I've been at it for about 2 hours. I think now would be a good time for me to take a break and get some food and come back in a couple of hours. Where I'm at is I need to be able to test the parser and dump the literals. Okay. All right, with that, I will catch you all maybe in an hour or so. Later.